All right, so it's always a good idea to color code the same way that we do on these. And so the goal here is to graph these equations. That's the point. And we're trying to graph them without making an input-output table, which is what we've done in previous lessons. So it says step one right here, identify and graph the y-intercept. Step two, and actually let's do that in yellow. All right, step one, identify and graph the y-intercepts. Step two, use the slope to graph more points. And then finally, oh, that's weird. Okay. It didn't like left like an impression there. All right, finally, step three. Right here, draw a line to connect the points. So that's what we're going to do. So step one is find the y-intercept. So in this problem, my y-intercept is the number adding or subtracting with x. So that is positive 3. Now what this is saying, what we're saying with this y-intercept is that this line crosses the y-axis at positive 3 on the y-axis. So I'm going to look for positive 3, which if they're counting by ones, it would be right there. That is my y-intercept, and that's the whole point of identifying the y-intercept, is so that I can put my first point. And that I know that that point is on this line. Now, step 2 is find the slope. So the slope is the number multiplying with x, which is, in this case, is 1 over 2. That's rise over run. So what I do here is I'm not plotting a point using that number. I am following a set of directions. From my y-intercept point, this slope tells me to run 2 units to the right and 1 unit up. So there's my slope. I ran 2 units to the right and 1 unit up based on my rise and run. And I'm going to keep doing that until I have a few points. I can also reverse both directions. Instead of going right 2 and up 1, I can also go down 2 and to the left 1. And I still fall on the same line. So I put a bunch of points, and once I have a few points there, the last thing I'm going to do is connect my dots with a line. And I always put an arrow on each end showing that this line extends further. Each of these points that I plotted using the y-intercept and the slope, they are all points or solutions to this equation. And that's how we graph a line using slope-intercept form. All right, let's take a look at another example. So, step 1, y-intercept. My y-intercept of this equation is the number subtracting with x, so that's -1. So on my graph, I find -1 on the y-axis, and I put a point right there. That's my first point. Step 2, find my slope. That's the number multiplying with x, which is -2 thirds. Always put if it's a negative fraction or a negative fraction, put the negative on the top, the numerator, okay? So this is my rise, and this is my run. So starting with the y-intercept, I'm going to run 3 units to the right. 3 units to the right, and I'm going to drop 2 units because I have a negative rise. I can keep doing that. 3 units to the right, drop 2 units. 3 units to the right, drop 2 units. I can also reverse both directions. I can go 3 units to the left and up 2 units. 3 units to the left and up 2. Just as long as I reverse both directions, then my points will be on the same line. So I've made my line, and there's my equation representing y equals negative 2/3 x minus 1. All right, let's take a look at number 3. So we're going to do number 3 together. Whoops. And then I'll have you try number 4 on your own here in a second. So step 1, find your y-intercept. That's always the number adding or subtracting with x. So my y-intercept in this case is negative 5. Go ahead and put that point for negative 5. So on the y-axis, that's 5 units down from the origin. There's my first point. Step 2, find the slope. So that's the number multiplying with x. So in this case, that's positive 2, which if it's a whole number, we put it over 1. And that's our rise and our run. So starting from the y-intercept, I'm going to run 1 unit to the right and 2 units up. And I can keep doing that. 1 right, 2 up. 1 right, 2 up. I can also reverse both directions and go 1 left and 2 down. And that will still be on the same line. Step 3, connect your dots and put an arrow on each end. So that's how you graph. All right, last example. Oh, they're both example 3. Look at that, Spear. Good job. Okay, so I want you to try this on your own. Step 1, identify your y-intercept. Step 2, find your slope. Step 3, draw your line. Okay, pause the video and try that on your own. Okay, so the y-intercept is always the number adding or subtracting with x. It's positive 2. So on the y-axis, I find positive 2 and I put a point. My slope is the number multiplying with x, so that's negative 4. I'm going to put that over 1, and that's my rise, and that's my run. So from the y-intercept, I'm running 1 space to the right and dropping 4 spaces down because this is a negative rise. I can continue doing that. 1 right, 4 down. 1 right, 4 down. I can also reverse both directions. 1 left, 4 up. 1 left, 4 up. And I should see a nice straight linear relationship through all of these points. And that's what your graph should look like. So, pretty simple. If you have not written everything down here, go ahead and do that now so that you can use this as a tool as you're going through your practices. Let us know if you need any help. All right, good morning, 8th grade. So today, guys, we're going to be looking at our lesson, I believe this is lesson 4. We are skipping lesson 3, and we're going straight to lesson 4. And guys, this is basically the meat of this entire unit. We just got done learning about slope, and we're going to continue to be talking about slope, but specifically in this lesson, we are focusing on graphing slope-intercept form. So we are learning how to graph these equations without using an input-output table. So back in lesson 1 and in the previous unit, we used an input-output table to figure out how to graph an equation. But in this lesson, we're going to learn how to graph without that. So we call this form of y equals mx plus b, we call this form slope-intercept form. So that's what slope-intercept form is. It's y equals mx plus b, where m is our slope. In other words, our rate of change, rise over run, or the change in y over change in x, or in other words, y2 minus y1 over x2 minus x1. All of that is slope. That is m. That is the number multiplying with x. All right, so let's put that in there. M is always the number multiplying with the x variable, okay? Super important. That's how you identify it. Now, B is the intercept part of this form. It is the plus or minus number, the number adding or subtracting with x, and we call this our y-intercept. All right, and the y-intercept is where the line crosses the y-axis. All right, and we identify this by figuring out which number is adding or subtracting from x. So just give me a second here to figure out how to lasso this. I don't think I can. It's all right. So the y-intercept is where the line crosses the y-axis, and that is also the y-intercept, which is the b, is also the number adding or subtracting with x. That's how we identify it, okay? So we're going to get a little practice identifying slopes and y-intercepts. So let's start by, we're going to color code this. So we're going to put our blue M's for slope. And then we'll put our yellow B's for y-intercepts. We're going to do this for every problem. Okay, so now let's get to it. So notice that when we are in slope-intercept form, which is y equals mx plus b, that's what we see at the top, notice that the equation is solved for y. So when we are looking at an equation that is solved for y, then we know that we are in slope-intercept form. Okay, so when we're in slope-intercept form, the number that is multiplying with x is our slope. That is our rate of change, our rise over run. And just so we're clear, the x is not a part of the slope. So if you write 4x here, then you get the problem wrong. The slope is just 4, okay? We just use the x to find the slope. All right, it's the number multiplying with that. All right, on the second equation, y equals 2x minus 4, we're solved for y, which is good, that's what we want. And the number multiplying with x is our slope. The next equation, y equals 7x minus 5. Then this equation is solved for y, so we're in slope-intercept form. So the number multiplying with x is our slope. It's easy enough, okay? Now y-intercept, the y-intercept is the number that's adding or subtracting with x. Now notice at the top where we talked about we see the addition symbol right here. So there's one thing that you need to be aware of with this. So the addition symbol, if it's addition, then the y-intercept is positive. We have a positive y-intercept, okay? If it's subtraction, then we have a negative y-intercept. All right, and it might make more sense to not put parentheses there, but that's basically what that means. So if we see a plus sign, then the y-intercept is a positive number, and that's where the line crosses the y-axis, which I'll show you here in a second. So in this first equation, y equals 4x plus 2, since that is plus 2, our y-intercept is positive. In the second equation, we see minus 4. So that means our y-intercept is negative. And in the third equation, again, we see minus 5, so our y-intercept is negative 5. And this is simply where we start our lines. It's where the line crosses the y-axis. It's an easy point to identify. Okay, so I've shown you a couple of examples. Go ahead and pause the video and see if you can try the next 3 on your own. Identify the slope and the y-intercept. Okay, so our equation is solved for y, which is what we want. We see y equals. So since it says y equals, then we look for the number that's multiplying with x to identify our slope. So our slope would be 1 over 2. That's rise over run. All right, our y-intercept is the number that's adding or subtracting with x. So that would be, in this case, positive 8. Now, all of this is going to help us graph these equations, which we'll see on the next page. But first, we have to get comfortable identifying the slope. So the next equation, y equals 5x plus 6. Easy enough. The equation is solved for y. So the number multiplying with x is our slope, and the number adding with x is our y-intercept. So the last example we see here on this row is y equals negative x minus 2. So identifying our slope is kind of weird. Our slope is never x, so that's not going to work. So we've got to figure out what number is multiplying with x. And the general rule of thumb here, guys, is if there is no number attached to x, then that number is a 1. And because it's negative x, then we call it a negative 1. So our slope in this case would be negative 1, and that because that's the number that's multiplying with x. And our y-intercept is negative. All right. So the last 3 equations are a little bit different because in previous equations we were always solved for y. Everything was solved for y, and that's what has to be true in order to be in slope-intercept form. But in these bottom 3 equations, none of these equations equal y. So the first thing that I'm going to have to do is I'm going to have to solve each of these equations for y. So what I mean is I'm going to take my equation and try to get y by itself. So in this case, 3 is subtracting from y, so I'm going to add 3. Now I can't actually add these two numbers together, so I just write it out as an equation. Put the x term in front and the constant in the back. The point of doing that, guys, is so that we are now in slope-intercept form and I can identify my slope and my y-intercept. So my y-intercept is positive 3 and my slope is negative 4. So I've shown you an example. Try the next one on your own. See if you can rework the equation and solve for y. So y is being subtracted by 7, so I'm going to add 7 to both sides. That cancels out what's over here, and I'm left with y equals. I put my x term in front and my constant in the back. I can't actually add those because they're not like terms. And now that my equation is in slope-intercept form, I can identify my slope and my y-intercept. So my slope is 3 and my y-intercept is 7. All right, last one. 5 plus y equals 4x. I've got to get y by itself, so I'm going to subtract 5 from both sides. I'm left with y equals 4x minus 5. I can identify my y-intercepts. a number subtracting with x, and my slope, a number multiplying with x. So you've seen quite a few examples there. Let's go to the second page.